Hello student, now see the next topic, construction of analytic functions. That means Milne-Thomson method. Actually Milne-Thomson method is very important, this topic. Okay. Now see the Milne-Thomson method. Actually Milne-Thomson method, there are two types. First, to find f of z. To find f of z when u is given, that is a real part is given, means using the Milne-Thomson formula, integration of f dash of z dz, which is equal to integration of u x of z comma 0 into dz minus I into integration of u y of z comma 0 into dz. That is, here integral and derivatives cancel. That is f of z, which is equal to integration of u x of z comma 0 into dz minus I into integration of u y of z comma 0 into dz. Here ux, which is equal to, that is a partial with respect to x. You can write dou u by dou x, comma uy is nothing but, that is a partial with respect to y, differential partial with respect to y, that is we can write dou u by dou y. You know already, you know this condition. Okay, and now see the second type, to find f of z when v is given, that is the imaginary part is given. Okay, can using the Milne-Thomson formula, integration of f dash of z dz, which is equal to integration of b y of z comma 0 into dz plus I into integration of b x of z comma 0 into dz plus c. That is, here integral and derivatives cancel. That is f of z, which is equal to integration of b y of z comma 0 into dz plus I into integration of b x of z comma 0 into dz plus c. Here c is a complex constant. Now see the conjugate. Conjugate means there are two conditions. So when real part is given, first condition, when real part is given, find the imaginary part. And second condition is, when imaginary part is given, find the real part. That means when u is given, can find the v value. And second condition, when v is given, can find the u value. These two conditions is like that conjugate. Okay, and now see the problems. Problems based on Milne-Thomson method. First is the first problem. Construct the analytic function f of z for which the real part is e power of x into cos y. Also find conjugate. Once again repeat the question. Construct the analytic function f of z for which the real part is e power of x into cos y, and also find conjugate. Okay, actually this problem can find that there are two conditions. First you want to find the f of z, and second condition to find the conjugate. Okay, first find the f of z. Okay, first is it listen, given real part is that is a real part u is given. Actually what is given the real part in this problem, that is a real part e power of x into cos y. That is, you want to take u which is equal to e power of x into cos y. First find the dou u by dou x, that is a partial with respect to x. Okay, that is dou u by dou x, which is equal to dou u by dou x. You can write the ux, which is equal to, so differentiation this value. Already you know, first you want to differentiation partially with respect to x when keeping a y is a constant. Suppose you want to apply partially differentiation with respect to y, mean keeping x is a constant. Already you know this condition. Okay, now want to using the partial with respect to x. Okay, that is ux, which is equal to e power of differentiation of e power of x value, e power of x into cos y. Cos y is a constant value. Okay, so e power of x into cos y, that is equal to, here to substitute the x and y value, here instead of substituting x value x comma y, that is x value want to substitute z and y value want to substitute the 0. So substitute this here, that is e power of x value, that is x value to substitute the z, that is e power of z into cos y. Y value what you have to substitute here? 0, that is a cos 0, that is e power of z into cos 0 which is equal to e power of z into cos 0 value 1, that is substitute here e power of z into 1 which is equal to e power of z. Therefore u x of z comma 0 become the answer e power of z. And next find the dou u by dou y, that is dou u by dou y can take the uy, that is uy at the point z comma 0 which is equal to, again to take this u value with respect to y, dou u by dou y which is equal to, actually x is here with respect to y when x is constant, so e power of x into differentiation of cos y, okay, differentiation of cos y value minus sin y, that is u y of z comma 0 which is equal to multiplication here minus e power of x into sin y. Now to apply the point, u y of z comma 0, substitute the x and y value, that is x value want to substitute 0 and y value want to substitute 0, x value want to substitute the z and y value want to substitute the 0, that is e power of z into sin y value 0, that is sin 0 value 0, substitute here 0 into anything value 0, that is we got the answer 0. Therefore the u y of z comma 0 which is equal to 0, okay. And now by using Thomson method, first using the type 1, because why are you using the type 1? Because in this problem given real part, so that is here using the Thomson method, integration of f dash of z dz which is equal to integration of u x of z comma 0 into dz minus I into integration of u y of z comma 0 into dz, using this formula, okay. Now to substitute all the values ux and u value here, therefore the here integral and derivatives cancel, that is f of z which is equal to integration of ux value, what you got the answer ux value, that is a e power of z, okay, and uy value 0, substitute here, that is ux value e power of z into dz minus I into uy value 0 into dz, okay, 0 and anything value become 0, so in this term cancel, that is f of z which is equal to integration of e power of z into, what's the formula, e power of z plus c, so f of z value become the answer e power of z plus c. So first condition finished. Next we want to find the conjugate, okay. Second condition, what is asking the second condition this problem, find the conjugate. Actually find the conjugate means, actually already you know the condition conjugate, there are two conditions. When u is given, when that is a real part is given, when what you find the v value. So in this problem find the v value, that is u is given, find the v value, okay. So you take this condition, actually you take the f of z value, that is the analytic function value, you apply this value, f of z equal to, you take this value e power of z plus c, once again take this value e power of z which is equal to f of z which is equal to e power of z plus c. And next in this value replace complex numbers, f of z value f of z value u plus iv formula, okay, and z value the complex number x plus iy, substitute all the values here, that is f of z value is substitute here u plus iv which is equal to e power of x, z value x plus iy, that is expansion, this addition value, you can separate this value, you can write the e power of x into, can you write e power of x into e power of iy, that is e power of x, e power of iy, you know the formula cos y plus I sin y, okay, apply this formula. Next multiplication of e power of x value inside the value, that is e power of x into cos y plus I into e power of x into sin y. Actually what you find in the conjugate, actually find the u or v. In this problem actually find the v value. Okay, so find the v value mean can using the equating imaginary part, and we need for the v value mean that is want to find the imaginary part. Okay, that is equating imaginary part on both side. Here left side value what is the imaginary part, that is I use a real value and imagine I coefficient is a imaginary value, that is a v is a imaginary value. Okay, that is v equal to here the right side values of imaginary part I coefficient value e power of x into sin y. Therefore the v which is equal to e power of x into sin y, this is the conjugate value. Okay, this answer. Okay. And now see the second problem. Determine the analytic function w which is equal to u plus iv if u which is equal to e power of 2x into x cos 2y minus y sin 2y. Also find its conjugate. In this problem asking two conditions. First want to find the f of z value, and second condition to find the conjugate. There are two conditions this problem asking. Okay, now see the solution. Find f of z. First you take the given condition. Given, actually this problem real part is given or imaginary part is actually this problem u, that is a real part. Okay, so this problem real part is given. Okay, so we take the u values. Given real part is u which is equal to e power of 2x into x cos 2y minus y sin 2y. The sin 2y. Actually this has a two function here. E power of 2x is a one function and x cos 2y minus y sin 2y is a another function. Okay, there are two functions. So can using the uv formula. So first to find the dou u by dou x. That is a dou u by x can take the ux of z comma 0. Differentiation this value using the uv formula. First this you take the u, and this value take the v value. You know that the differentiation of uv formula. What's the differentiation of uv formula? U v dash plus v u dash. Okay, so apply this formula. Now consider the e power of 2x value, consider u, and x cos 2y minus y sin 2y consider the v value. So u v, apply the uv formula. Now using the uv formula, that is dou u by dou x, that is ux which is equal to u v dash e power of 2x into differentiation this value, that is x value, differentiation of x value 1 into cos 2y is a constant, that is a 1 into cos 2y minus y, here y is a constant, and sin 2y is also y, is a, both are constant, that is become differentiation of constant value 0, that is minus 0 plus v u dash, that is v value x cos 2y minus y sin 2y into u dash. U value what here? E power of 2x. E power of 2x differentiation this value, that is you can write the 2 into e power of 2x. Okay, and now can apply the points u x of z comma 0. X value to substitute the z and y values want to substitute the 0. That is e power of 2 into x value what you substitute here z, that is e power of 2z into cos 2 y value 0, cos 2 0 plus z into cos 0 minus y value 0. So y 0 into anything value 0, so becomes 0 minus 0 into 2 into e power of 2x here, that is a 2 into e power of 2z. Substitute the values. Okay, therefore the e power of 2z into multiplication this 0, that is a cos 0 plus z into cos 0 value 1 into 2 into e power of 2z. Cos 0 value no 1, that is e power of 2z into cos 0 1 substitute here, e power of 2z into 1 plus 2z into plus multiplication this value 2z into e power of 2z. Okay, these two terms, which one is common here? E power of 2z, e power of 2, that is e power of 2z is a common, take outside, that is e power of 2z into what is the remaining value? 1 plus 2z, that is a 1 plus 2z. Therefore the u x of z comma 0 value, you got the value e power of 2z into 1 plus 2z. First condition over. Next find the dou u by dou y. Again to take the u real value, you take the u value and using the partial with respect to y. Okay, again by using the differentiation of uv formula, you take the partial with respect to y, mean that is first you take dou u by dou y, that is equal to e power of u y into z comma 0, which is equal to u b dash, u value e power of 2x into v dash with respect to y. Okay, with respect to y differentiation this value, what do you write here? X constant, so x into differentiation of cos value, differentiation of cos value, you know, minus sin 2y into again to differentiation this 2 value into 2, that is you can write the minus 2x into sin 2y. Okay, so right here minus 2x into sin 2y minus here what we have, y into sin y one function and sin 2y is another function. There are two functions here. Again by in this term, again by using the uv formula. Okay, u v dash plus v u dash. Okay, so u v dash minus y, okay, minus y into sin 2y, differentiation of sin 2y, sin 2y you know cos 2y. Okay, cos 2y into 2, okay, 2 plus v u dash plus u v dash. Okay, so sin 2y into y, differentiation of y value 1. Okay, and next multiply plus minus v dash. Okay, so clear. Next plus v u dash plus v u dash plus u v dash. Okay, so differentiation and plus u v dash plus v u dash. Okay, so u v dash over plus v u dash, v value what here? X cos 2y minus y sin 2y into u dash. U dash what we have here? U value e power of 2x is a u value. So differentiation of this value, actually x is a constant because what you are using with respect to y mean keeping x is a constant. So differentiation this value becomes 0. That is you have to write the 0. Okay, and next u y of z comma 0, which is equal to, and have to apply the point x and y value. X value substitute the z and y value substitute the 0. That is e power of 2z minus 2z into sin 0 minus y value substitute 0, in this term becomes 0 plus sin 2y, that is a sin 0 value 0 plus 0 into anything value multiplication, this value becomes 0, that is a plus 0. Okay, therefore the e power of 2z into 0 minus 0 plus all the terms become 0. Therefore the finally u y of z comma 0, which is equal to 0. Okay. Next, by using the Milne-Thomson method formula, integration of f dash of z into dz, which is equal to integration of u x of z comma 0 dz minus I into integration of u y of z comma 0 into dz. Okay. Here integral and derivatives cancel, that is f of z, which is equal to integration of ux value. What do you got the answer? E power of, what's the ux value? See, ux value e power of 2z into 1 plus 2z and uy value 0. Here substitute these two values in this formula, Milne-Thomson formula. That is u value, ux value e power of 2z into 1 plus 2z into dz minus I into u value 0. Okay, into dz. This term cancel. Therefore the integration of e power of 2z value multiplication inside the value e power of 2z plus 2z into e power of 2z into dz minus 0. Next, now to integration this value, integration of e power of 2z into dz plus 2 constant value take outside, 2 into integration of z into e power of 2z into dz. If we take the first term, integration with respect to z, integration of e power of 2z value, e power of 2z divided by actually the power value 2z, again to differentiation this value, that is divided by 2, e power of 2z divided by 2 plus 2 into actually the other two function. Okay, by using the integration by parts formula, now to consider the u value is equal to z and dv value is equal to e power of 2z. Differentiation, actually u value is a differentiation, d value want to using the integration. Differentiation this value, that is du which is equal to z value, differentiation z value 1 into dz, that is not integration this value, to integration on both sides, integration on both sides, that is integral under d value is cancelled, therefore the v which is equal to e power of v which is equal to integration of e power of 2z value, e power of 2z divided by 2. Okay, by using the formula, you know the formula, what's the formula here? Actually uv minus integration of v du, using this formula, uv minus integration of v du, that is 2 into uv, what's the u value? Z into v value e power of 2z divided by 2, substitute here this is formula, z into e power of 2z divided by 2 minus integration of v du. Okay, so minus integration of v du, that is minus integration of v value e power of 2z divided by 2 into dz. Okay, therefore e power of 2z divided by 2 plus 2 into z into e power of 2z divided by 2, again integration this value, integration of e power of 2z value, that is e power of 2z divided by 2 into 2 value, you can write the 4, that is for the minus e power of 2z divided by 4. Okay, therefore e power of 2z divided by 2 plus the outside values up to multiplication inside the value, 2z into e power of 2z divided by 2 minus 2 into e power of 2z divided by 4. Now to cancel this value, 2 2s are 4, here 2 and 2 values cancel. Finally want to write e power of 2z divided by 2 plus z into e power of 2z minus e power of 2z divided by 2 plus c. Here plus and minus values cancel, therefore finally f of z which is equal to, we got the value z into e power 2z plus c. So first condition x. Next, first condition over. Next, find the conjugate. Find the conjugate means, that means what value you have to find, that means to find the v value, because in this problem given real part. So when u is given, that is a real part is given, means can find the v value. Okay. Again to take the in this values, f of z which is equal to, again to want to write f of z which is equal to, if we find the conjugate mean want to take the f of z value. So f of z which is equal to, we need the f of z value, f of z which is equal to z into e power of 2z plus c. So in this value can replace with the complex numbers. So f of z value, you know the formula u plus iv, substitute here, which is equal to z value, the complex value, x plus iy, substitute the value, into e power of 2 into, again to substitute the z value, e power of 2 into x plus iy, that is x plus iy into e power of multiplication this value and separate this value, can write the e power of 2x into e power of I 2y. Okay, that is x plus iy into e power of dx. Here the e power of I theta formula, that is you can using the formula e power of I 2y can take, you can write the formula cos 2y, can you write cos 2y plus I sin 2y. Okay, and next multiplication this value, outside values of e power of dx value, multiplication here, inside the value you can write the e power of dx into cos 2y plus I into e power of dx into sin 2y. Again multiplication these two value, first multiplication of x value, x into e power of dx into cos 2y plus I x into e power of dx into sin 2y plus next multiplication of iy value in this value plus I y into e power of dx into cos 2y plus I into I value I square into y into e power of 2x into sin 2y. I square value no minus 1, substitute here. And next separate in the real and next add the terms of real part and add the terms of imaginary part. Separate the real and imaginary part and then to find the v value. So find the v values mean can need for the imaginary part. Okay, so equating the imaginary part on both sides, equating the real imaginary part on both sides, that is v which is equal to the right side values have the imaginary part e power of dx into x into sin 2y plus e power of dx into y into cos 2y. These two terms e power of dx common take outside, that is v which is equal to e power of 2x into x sin 2y plus y cos 2y is a conjugate of v values answer. Okay,